here are solutions to perfect problem 6 for Math 243. This is the one where we claim that LeBron James chokes in big games. So chokes, he does worse in big games. To try to support this claim, he points out that LeBron only scores this many, or he scores this many points per game, but in these 40 big games, he only scores this many points. And suppose we know that the standard deviation in all games, that's key, is 8. So I think what I would do maybe is go through and pull out the information they give us. The standard deviation in all games means we're talking about sigma, population parameter here is 8. Let's see, there are 40 games in our sample. This tells us that n is 40. In these 40 games, he scored 24 points per game. So this is a sample average. This is x bar is 24. And in all games, not just these big games, but all games, we got our average is 27.6. The symbol we use for this is mu naught is 27.6. The reason we use mu naught here is because, maybe I'll write up here, mu is the population average points per game in all big games. So we've kind of already used up mu. So this right here, this is the population average of all games, not just all big games. But if our null hypothesis is correct, then these guys are the same. So we're going to call this mu naught to represent that it has something to do with the null hypothesis here. Mu naught is 27.6. Okay, if you know all that, we can now state the null and alternative hypotheses. Then null hypothesis, H naught. Alternative hypothesis, we'll write H1. Or sometimes you can write HA here. They're the exact same. And to write it using symbols, what we would do is we would say that our null hypothesis is that mu is just the same as mu naught right here. That is, population average in all big games is the same as is population average in all games. That there's no difference between big games and all games. That mu is equal to 27.6. But our alternative hypothesis is a little bit different. Our alternative hypothesis is that it kind of corresponds with our claim here, that he chokes in big games, that he does worse in big games, that mu, in fact, is not 27.6, it's something less than 27.6. You don't have to write this here, but it might be helpful to note that because our alternative hypothesis is that mu is less than 27.6, we have a one-tailed test here. If this was not equal to, we'd have a two-tailed test. And it asks us to do this with symbols and to, again, do this using words. So what this is, our null hypothesis is saying, maybe I'll put a little arrow, is that the population average points per game in all big games is the same as his population average, is same as population average points per game in all games. That is, that it makes no difference if it's a big game or just a regular game, that he's going to score the same amount of points in total in all of the games, the population parameter there. And what this one is saying is that the population average points per game in big games is less. Is less than, maybe I'll just put an arrow, is less than this thing right here, that he chokes, that he does worse in big games. Okay, type 1 error, type 2 error. What a type 1 error is that you falsely, that might be spelled right, you falsely reject the null hypothesis. So what that's saying is that we conclude that LeBron plays worse in big games, when in fact he does not. And a type 2 error is kind of the reverse of this. Instead of falsely rejecting the null hypothesis, we falsely accept the null hypothesis. So in this case, we conclude that he does not choke, that LeBron does not choke in big games. But we did that incorrectly when in fact he does. Okay, describe what a type 1 error would be in this case and a type 2 error in this case. So I guess that's this. Calculate our test statistic. This is going to be, maybe I'll switch colors, a z statistic. If you want it formulaically, it's x bar minus mu naught divided by sigma over the square root of n. What it's saying is how many standard deviations above or below what we expected, mu naught, is our sample. So we got x bar was 24, mu naught was 27.6, and then our standard deviation is sigma over the square root of n. Sigma was 8, and n was 40. So we get this mess here. 24 minus 27.6 is negative 3.6. 8 divided by the square root of 40. If you stick that into a calculator, you get 1.265-ish. 1.265, give or take. So negative 3.6 divided by that standard deviation gives you approximately negative 2. If I round it to 2 decimal places, 2.85. So our test statistic is negative 2.85. Assuming a 95% confidence level, calculate the critical values and draw your rejection regions. You may want to add a sentence justifying the shape. Okay, so first of all, let me take care of this part. By the central limit theorem, because n is greater than or equal to 30, the shape of our sampling distribution is approximately normal. In other words, we can do this problem. We can do all this analysis. Kind of check the box. Okay, so we want to draw our rejection regions. So maybe I'll switch colors again. So here's our sampling distribution, which we can draw as approximately normal. That's a horrible picture. Let's try again. I don't know if that's much better, but good enough. Okay, we want a one-tailed test with 95% confidence level. And it's worth pointing out that this is actually a left-tailed test because our alternative hypothesis is that mu is less than 27.6. So down here somewhere, we got our rejection region. We want the area of our rejection region to be alpha. Alpha in this case is 5%, 1 minus our confidence level. So what we need to know is what is the z-score that corresponds, the critical value, what's the z-score that corresponds with 5% in the lower tail. Let's see, if there were 5% in both tails, that would be a 90% confidence interval, which you might have memorized is 1.645. So since we're over on this side, it's negative 1.645 as our critical value. And you can also look this up on the tables. If you looked up 0.05 as an area, your critical value would be negative 1.64, 1.65, something like that. Okay, and the whole point of drawing this rejection region, here's our critical value down here, here's our rejection region is the shaded part, is to kind of compare that with our test statistic. So maybe I'll add that to the picture too. Negative 2.85, if this is negative 1.645, negative 2 is even further to the left, I don't know, somewhere out here, negative 2.85. So even though it doesn't ask you to do so, I'm going to go ahead and put my test statistic into the picture, because that'll help me on part E where I state my conclusion. The idea here is our test statistic is in the rejection region. So maybe I'll even write that, because test statistic is in the rejection region. There is sufficient evidence. There is sufficient evidence. Maybe I'll even state how at alpha equals 0.05. So at this level of certainty, 95% confidence, there is sufficient evidence to reject the null hypothesis. And conclude that the alternative hypothesis is correct, that LeBron scores less points in big games. In other words, that he chokes. I think that is the end here. That's the end of this perfect problem.